Assalamualaikum, my name is Muhammad Haikal bin Abdul Aziz. My message number is AA210273. I'm from Group 2. Now I want to talk about intro flip-flop. Flip-flop is a circuit with two stable states that can be utilized to store state information is called a bistable multiplicator. Okay, also referred to as a flip-flop or latch. The circuit can be changed state by responding to signal applied to one or more control input and one or more output. In sequential logic, it is the synthesis part of store. Flip-flop and latch are essential part of digital electronic system used in computer communication and many other kind of system. Flip-flop and latch are used as data storage component. A flip-to-flop is a device that holds one bit of data and has two states. One of the switch corresponds to a one and the other to a zero. Electronic speed of this type of circuit as sequential logic, and it can be utilized to store state information. A finite state machine's output and following state depend not only on the input but also on the current state and by extension past input. Additionally, it can be utilized for pulse counting and to synchronize variable time input signal to a reference timing signal. Flip-flop can be asynchronous, opaque, or transparent and can be level or edge-triggered, synchronous or clock. Historically, flip-flop has been used to refer to level trigger and edge trigger circuit that employ gate to store a single bit of data. The term flip-flop is now exclusively used to describe timed circuit. The simplest one occasionally referred to as transparent latch. Level sensitive flip-flop is referred to in this language as a transparent latch, whereas an edge-triggered flip-flop is referred to as a flip-flop. In any case, a latch is a device that stores any number of bits of data using a single trigger, whereas a flip-flop is a device that only stores one bit of data. Edge trigger and level trigger may be used to avoid any misunderstanding. Type of flip-flop. SR flip-flop. To engage and standard NOR flip-flop are used to construct the SR flip-flop. Regardless of the S and R I/P value, the O/PS of the two AND gate remain at 0 as long as the clock plus is 0. Information from the S and R input can pass through the basic FF when the clock pulse is 1. The clock pulse occurs both O/PS to 0 when S equal R equal 1. The state of the FF is understood when the clock pulse detached. JK flip-flop. The SR flip-flop is simplified in a JK flip-flop. The input of the J and K flip-flop operate similarly to the S and R input. The flip-flop entered is its complement state when input 1 is applied to both input J and K. The flip-flop's record is displayed below. It is possible to design the JK flip-flop so that the O/P Q is ended with P and with P. The flip-flop is only cleared by a clock pass in this state if the output was previously 1. The output is ended with J and CP in similar manner so that the flip-flop is cleared during a clock pass only if Q was previously 1. You can see the one J. Okay. D flip-flop. The D flip-flop, which is depicted in the illustration, is all the remain of the SR flip-flop when it is simplified. The D flip-flop's input is connected directly to input S and its complement is connected to input output R. While a clock pass is present, the D input is simple. The flip-flop is shifted to the set state if it is 1. Otherwise, the flip-flop enters a clear state if the value is 0. T flip-flop. The JK flip-flop has a single ISLP version called the T flip-flop, sometimes known as a toggle flip-flop. This flip-flop operates in the manner described below. The next state that the T will create will be comparable to the current state when the input of the T is 0. It follows that current state and the future state will both be 0 when the T input flip-flop is 0. The present state, however, is inverse to the following state if the T is isolated is 1. As opposite to this, thus the current state equals 0 and the following state equal 1 when T. In digital electronic and digital system, counters are sequentially used. They are employed to determine how many events took place over a certain period. A counter is typically used to count the pulses that enter a circuit's input throughout a given time. A counter is a sequential circuit that generates a certain count sequence. According to the language of digital electronics, it is a piece of electronic equipment that count clock signal. Since counter must recall the previous state of a digital circuit, flip-flop are a necessary component of their design. Next, register. Flip-flop can store a single bit of data, i.e. 1 or 0. Multiple bits of data are stored in register. Therefore, flip-flops are utilized to construct register. A register is a device that is used to store information, according to digital electronics. Since only one flip-flop can store one bit of data, and flip-flops are connected in a specific way to store n bit of data. For instance, a computer requires a set of 16 flip-flop in order to hold 16-bit data. Depend on the need, a register input and output might be serial or parallel, byte or word refer to the collection of data bit the register hold. A register is what is created when several flip-flops are connected in series. shift register are registers that allow the transfer of store information between them. Next, data storage. Flip-flop store one bit at the time in the digital circuit. Flip-flop can be coupled in series and parallel to form register, which can store more than one bit. A register is merely a means of storing data for several bits. Each each of which will flip-flop one bit of information 0 or 1. Thus, a 4-bit register is made up of 4 separate flip-flop, each of which can store 1 bit of data at a moment. Net data transfer. The data can also be transferred expressly using flip-flop. A shift register is used for this. A shift register is a register that has the ability to move or transfer its data internally without altering the bit order. It might be booked with the ability to move or transfer data to the left or right. When a clock pulse is applied, the data is shifted of transmitted one bit at the time. Shi- The shift register can be used to store data temporarily when bit shifting is necessary. See, the shift register is utilized for amplification and division. The SR, JK, or D flip-flop can be used to construct the shift register. That's for all from me. Uh, Now I want to pass to my friend to continue the presentation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Sharif Ahmad Tamizi and my matrix number is AA210652. Today I will explain about counter. First, counter. Counter is a device that store and occasionally display the number of time a specific event or process has occurred in digital logic and computing, frequently with a clock. The most typical kind is a sequential digital logic circuit, which has several output lines and a clock line. Counter has been divided by two: a synchronous counter and synchronous counter. In an asynchronous counter, only the first flip-flop is driven by the main clock, and the remaining flip-flop clock input are driven by the result of the flip-flop that came before them. With the help of the following graphic, we can synchronous counter, in contrast to a synchronous counter, have a single global clock that drives each flip-flop, enabling concurrent output modification. One benefit of synchronous counter over asynchronous counter is that they can function at greater frequencies because each flip-flop receives the same clock, eliminating cumulative delay. Next is the difference between a synchronous counter and synchronous counter. For the synchronous counter, faster than a synchronous counter during operation. Synchronous counter is slower than the synchronous counter in operation. All flip-flop are triggered with the same clock simultaneously. For the synchronous, different flip-flop are triggered by different clock, not simultaneously. For the synchronous, its planning and implementation is complicated due to the increasing number of states. For the asynchronous, planning and implementing is very easy. For the asynchronous, also called parallel counter, and the asynchronous also called by the serial counter. Next, for the finite state machine (FSM). Finite state machine, also known as a sequential circuit, it can be seen as synchronous counter with irregular sequence and has two types for finite state machine. Type of FSM is more machine and melee machine. For the more machine, next state output depend on the present internal state only. For the melee machine, next state output depends on the present internal state, but not only that, also with input at that particular of time. Design of a state machine. First, state diagram. All state transition when the clock is triggered are shown by the diagram number of flip-flop equal to number of bit. The second is state table. All current condition along with the net condition are listed. And the third excitation table listing all of all JK extension of all FFS for the next state transition occur. The last one is K-map. Simplified logical expression for all J and K are determined. The next is register. There are many flip-flop in a register. Single bit digital data is stored using a flip-flop by combining multiple flip-flop. The storage capacity can be enhanced to store a high number of bit and n-bit register with an n flip-flop must be used to store an n-bit word. The register is utilized for a variety function. The CPU uses the register to carry out the operation. The system fed input will be stored in the register. The system output will be stored in the register. The register are capable of carrying out following operation. There are two basic functions of a register in a digital circuit. The first is data storage for the memory device, and the second is data movement, shift capability in transferring data. Data storing. The storage capability of a register is the total number of bits, ones and zero of digital data it can retain. When a 1 is n on D, Q become n1. At the rising edge of the CLK, well, when the 1 on the D is removed, Q is still remain high to 1. The last one is example of application. For the counter, the application is digital clock, frequency counter, analog to digital converter. With some to its design, the counter can be used as a frequency divider circuit, counting time in a timer like electronic device like an oven and washing machine. And the last one is we can design a digital triangular wave generator by using a counter. For the FFM, the application is vending machine, traffic light, video game, text parsing, CPU controller, and protocol analysis. And the last one is the application of the register in storing data in digital form, can hold data and address, generate a sequence of zeros and one. Therefore, it is used as a sequence generator. Used as a parallel to series converter, which converts parallel data into the series data. Used as a series to parallel converter, which converts serial data into parallel data and generate sequence of 0 and 1. Therefore, it is used as a sequence generator. That's all from me. Thank you.
Hello, my name is Ajan Abdul Zaki. My trade number is AA211294. So, thank you for my friends, and I will continue the presentation. So, the first one is finite statement FSM. Finite statement machine FSM. Simulation using Tinkercad. Design a more machine using 3JK block for transition set like your own without counting sequence. Just like this, 001 is 1, 011 is 3. So sequence IC using IC circle 473 to draw and other logic gates to make the circuit. So for the next one is next stable state. Next stable state is the F preset state and next state. So for the preset state, QC is 0000 and after that, okay. So for the next set is you have to watch this QZ 0 0. That means 0 to yeah, yeah. Dah berapa kosong. Situ pula. Situ pula. So the C uh, it starts from 000 and it finish 010, because as we can see here, 0, this is 000, and it will go to this 010. That is the statement for this next state. That's it. So on to the next one is excitation state. So for the excitation state, we have the present state, next state, and flip flop C, flip flop B. We using flip flop JK and flip flop A. So for this one is that we have a formula. For the next state, we take QC present state and QC next state 01, means that it will come out as the output 1x, and go on for the next QB and QA and the below them. So for the KMAT, you have to use this flip flop JK, and as you can see that we got B, uh, BA and B bar A, and that's input for the JK FF flip flop C, J input and K input, and the others are the same. 1 A plus C bar B. So on to the next one is Tinkercad simulation. I have the Tinkercad. So this is a Tinkercad simulation that our group make. So if we turn on and start the simulation first, and we turn on the switch, will come out the result that we got in the report.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Amirul Imran bin Abdul Talib. My number metric is AA210186. So I am doing the circuit by using the Logisim software. So first, before we test the result, I want to share with you the component. To find the component to build a circuit. Okay, first we need to go to the project here to find the component. So as you can see, to find the JK flip-flop, just go to the memory, and then you can find the JK flip-flop here. So there is a JK flip-flop. Okay, to find the component of inverter, a NOT gate, just go to the gate and then you can find a NOT gate here. And then from the JK flip-flop, you need to put the name of the JK flip-flop. Just insert it here. QA, and then QB. Just put a name, just follow by this wire. just jump there for A. Then for B, here, C, here, Q, D. Okay. Then just to make it more shown, to make it more clear, just make here, and then like that. Okay. To make it clear. Okay, done. Okay, when you have done that, so you have complete your circuit. Or before that, if you want to find the clock, just go to the bottom. Sorry. And then also, where is the clock? I forgot about it. So here is the clock. Here is the clock. Okay. Okay. So when we have complete the circuit, let's test the result of the circuit. Okay. First, we need to refer to the table. So when the A, B, C, D is 1, also 1, 1, 1, 1, and the output will be 0, 0, 0, 0. Also, if the clear 1 and the output is 0 too. Okay. Let's see if we try first. 1, 2, 3, and clear. So first, from the circuit, we can see, from the table, we can see if the input is all 1 and then the clear 1, the output will be 0. Okay, so let's try it if the input is 1 and then the clear 1 too. So as you can see, the output will be shown 0. Okay, let's look at the table. If the clear is 0, okay, so the input is all 1 and then the clear is 0. So as you can see, the output also will be 0. And then the next step is parallel load asynchronous. So what is if the input is 1, 0, 1, 1, if the B is 0? Okay, 1, 0, 1, 1, and then the clear is 1. So when we look at the output, we only shown that the B is only 1. So it is same with the output of the table. Okay, let's try another else. If the clear asynchronous, try it again. Clear asynchronous, 1, 1, 1, 1. So again, the output is 0. When you can see like that. Okay, so that's all for the logic sim, and thank you.